This is the last of the index laws that we're going to be looking at, and it's index law number 6, also called the fractional index law. Okay, so far we've looked at what happens when you multiply terms, when you divide terms, when you raise a power to a power, when you raise a term to the power of 0, when you raise a term to a negative power. Finally, we're up to fractional powers. So a term raised to a fractional index can be expressed in surd form. So if you remember surds, sort of that tick symbol there called the radical sign. An index of half actually means a square root. Okay, so that's the square root sign. So for example, 2 to the power of half really means square root of 2. So it's actually two different ways of writing the same thing. Okay, so we're used to, sort of pressing the square root key to find the square root of a number. Okay, so 1.414. So if we do 2 to the power of, so that's that x with a square, and we can raise it to a power of a half, you'll get the same thing. Okay, so basically it's just two different ways of writing exactly the same thing. An index of 1 on 3, or index of a third, means the cube root. Okay, so it's just got a 3 there, just in front of the surd. Okay, so as an example, 8 to the power of 1/3 is really the cube root of 8, which is in fact 2, since 2 times 2 times 2, okay, gives you 8. But not all answers end up nicely. You could end up with a nice, horrible looking decimal, right? It sort of goes on forever with no known pattern. So as a general rule, okay, x to the power of 1 on n, okay, so n could be really any value, really. Doesn't really matter, as long as it's not 0, of course. So x to the power of 1 on n is equal to what we call the nth root. Okay, of x. Okay, and of course, for this to make any sense, n can't equal 0. It can't have 1 on 0, for obvious reasons. All right, let's have a look at some examples. Okay, if you like at this point, if you want to pause the video and give these questions a go, you're welcome to do so. You can pause it, and unpause it, and check your solution, of course. So let's evaluate each of these expressions. So 676 to the power of half, okay, is really the same as square root of 676. There's two ways you can do this. Either just press the square root button and square root of 676 and you get 26. Okay, so I'm going to put that answer down here like that. Or you could write it as an actual power if you like. So 676 to the power of 1/2, so 1 on 2, and obviously it would give you the same result. Okay, what about 729 to a third? Okay, to the power of a third. That's the same as cube root of 729. I want you to get used to this conversion between index form and surd form. This is why I'm doing it this way, so you can see that. All right, and now there is an actual cube root button on this calculator. It's a dedicated one, just above the square root key. It's in yellow. So if you press Shift, all right, press the square root key, it brings up the cube root. So it's a sort of kind of like a hotkey. Right? So they're the two most common surds that we use: square root and cube root, of course. 729, and we get 9. All right. So fairly straightforward examples. What about this one? 59,049 to the power of 1 on 10. Okay. Now this is where we're going to enter in the 10th root. Now we could just enter in this power, type it in directly, 1 on 10. But this is really the same as the 10th root of 59,049. So let's do it this way, just so we can learn that there is this function on a calculator called the nth root function. So just above the power key, again, I'll move a little bit closer there. You can see that looks like a square root with a little box there. Close the yellow box. So Shift and the nth root key there, and it was 59,049. Okay, whoops, put it in the wrong spot. Do it again. Okay, 10th root of 59,049. Okay, so what you fill in first is which nth root is it? That's a 10th root, and then 59,049. press equals, and we get 3. Okay, so that means that 3 times 3 times 3 times 3, 3 to the power of 10 in other words, gives you 59,049. That's a way to check, make sure you got the right answer. 3 to the power of 10, and we get 59,049. All right, it's always a good idea to check your answers as you go along too. So far so good. Part B, write each expression using a fractional index. So kind of going back the other way now, going from surd form now back to index form. Okay, square root. What index represents a square root? Okay, if you said half, well done. So we could write that as 10 to the power of half. What about part 2? Cube root of 100. Okay, we could write that as 100 to the power of 1 on 3. Okay. What about this one? Just because it involves algebra doesn't mean it's any harder than anything else. Okay, it's the same rule applies. Okay, except the surd, or the surd symbol, acts as a bracket. In fact, it acts as a grouping symbol. So we could write that as xy, okay, in brackets, and to the power of 1 on 5. Okay, so just remember that. It's like fractions. Okay, so if you recall, for example, x plus y over 2, x plus y, the fraction line acts like a bracket, in fact. Okay, or a set of brackets. So back to this. Okay, so part C, evaluate each expression correct to 2 decimal places. Same as everything else, you can just type it in directly. 1/3, what's that? Okay, what surd does that correspond to? Okay, and if you said that's a cube root, oh, of course, well done. All right, doing well so far. Cube root of 100, 4.64. Okay. 4.64. Okay. 8 to the power of a half, that's a nice easy one. Of course you're going to say, but that's just a square root. 2.83. And last one, just because there's a negative number in there doesn't mean it won't work necessarily. Hopefully this one will. Okay. Negative 0.1 to the power of 1 on 5. Okay, again, you can enter that in directly if you like. Some of you might think, oh, hang on, 1 on 5, isn't that 0.2? Sure is. Okay, so that's equal to negative 0.63. That's also the same as the 5th root. Okay, so remember that nth root button there. So I might try that and just to confirm, does it work? So we want the 5th root of negative 0.1. Yeah, I think that's a little bit easier there rather than typing in all these fractions and what have you. Yep, nice and easy there. All right, let's have a look at, here's another set of examples that we'll have a look at. These ones are a little bit different, okay? A bit more extended this time. Everything we've looked at so far has involved an index 1 over something. 1 over 2, 1 over 3, 1 over 4, 1 over 5. Okay, so far, so fairly sort of straightforward sort of indices and conversions to surd form. What about these ones? So, for example, 9 to the power of 3 on 2. What's going on there? I'm used to 1 on 2. What's this 3 on 2? What's going on here? This is actually a combination of 2 rules. This is the power to a power rule. Remember index law number 3? If not, might want to go back and revise that one. But this is a combination of index law number 3 and index law number 6. Okay, the fractional index law. So let's see how that works. So we need to split them up. Okay, so that's the same as 9 to the power of a half. I like that one because I could work that out quite easily. That's just a square root of 9. But then you've got to raise it to the power of 3. You might think, hang on a moment, why does this work? Power to a power law, index law number 3 states what? Power to a power, what do you do to the indices? You multiply the indices. Half times 3, last time I checked, was 3 on 2. I think the system works. But the good thing about this is 9 to the power of half, that's just 3 to the power of 3, isn't it? Well, 3, but then we're going to raise it to the power of 3. Okay, I think that's easy enough that we can say, yeah, that's just a square root of 9. 3 to the power of 3, well, that's just 27. Okay, and just in case you don't believe me, we could even type it in directly. 9 to the power of 3 over 2. All right, drum roll. 27. Very nice. What about this one? 16 to the power of 3 on 4. Think we can do the same thing there? Did I say 3 on 4? No, 5 on 4. I'm in trouble reading my own writing there. 16 to the power of 5 on 4. But then again, we can work out 3 on 4 if we wanted to. Okay, can we do the same neat little sort of, I wouldn't say it's a trick, but you know, apply a strategy here? Of course we can. So 16 to the power of 1/4. The reason why I say that is because again, it's something that can be quite easy to work out. That's the power of 5. I like this one. 16 to the power of 1/4. Think of a number that when you multiply it to itself 4 times, you get 16. 2 times 2 times 2 times 2. Yeah, counted 4 of them. There you go. That's just 2, right? To the power of 5. And that's just 32. Alright. Again, last time I checked. Hopefully that's going to work. Alright, so I'm going to play any tricks, this calculator. Hopefully not. 5 on 4. And we get 32. Now, you might be asking, what if I reverse those two? So reverse the 5 and the 1/4, switch them around. Would it still work? Would I get 32? Now, if you know index law number 3, what do you know about multiplication? Can you swap terms around? And will that change the answer? Of course not. You know that, right? Just like with addition. 1 plus 2 is 3, 2 plus 1 is 3. 2 times 3 is 6, 3 times 2 is 6. Swap them around, see what happens. Right? So put that in brackets. So 16 to the power of, instead of to the power of 1/4, I'm going to make it to the power of 5. Right? Then to the power of 1/4. Okay, whoops. Okay. So notice I've swapped the 1/4 and the 5 around, those two powers around. Would you get the same answer? If you said yes, we get 32. System works. I like that. All right. What about 64 to the negative to the power of negative 2 on 3? This one has 3 rules applying. You've got the negative index law. All right. You've got the negative index law. You've also got the power to a power index law number 3, index law number 5, and index law number 6. Now, yeah, you can apply them all. There's 3 rules, sort of all in one. How nice. All right. Can we break this down a little bit? What do you think you'd apply first? Negative numbers can be quite nasty. I don't like maybe negative. Let's be positive, right? Let's convert this to a positive index first. So I might, just to save a little bit of space, I'm going to write it here. Negative index means reciprocal. All right. So that's going to be written as 1 over 64 to the power of 2 on 3. Now I don't have to worry about the numerator. It's just a 1. Leave that alone. Now we can just worry about the denominator. Now it's a positive index. Now this looks like something that I've done before. And that's the beauty of maths. Maths is really divide and conquer. It's really about taking up, sort of a complicated problem and really splitting it up into sort of a series of smaller ones, or breaking it down into small pieces, and then bringing all the pieces together again into our solution in the end. All right, 64 to the power of 2 on 3. Well, let's might just sort of write it over here to give myself a bit of space. 1 over, that's 2 on 3. That's really the same as 64 to the power of 1 on 3, but there's 2 of those thirds, so I have to raise it to the power of 2. Okay. Again, I just think of sort of how do I split the 2/3 up so that it's a product of a fraction and maybe a whole number. 1/3 times 2 is 2 on 3, and the beauty of having the 1/3 here applied to the 64 is because that's just the cube root of 64. And if you know your square roots, cube roots, square numbers, cubic numbers, cube numbers, you can sort of recognize this, and that's nice. So 1 over cube root of 64, okay, is 4, and squared, and that's really equal to 1 over 16. All right, let's see if it works. All right. Am I right? I don't know. You might think, oh, I'm not sure this time. Could I be right? And SD button, 1 on 16. All right, so that's decimal form, but no, I like it. So far, so good. Right. All right. Last 3. What about this one? cube root of x squared. So this is writing each expression now using a fractional index. So not so much computation or calculation this time. It's just really about the language, the language of these fractional indices and the language of algebra. Convert it back now, okay, using a fractional index. Okay, now x squared, that's just the same as x squared, nothing changes there, but that's the cube root, that's the power of 1 on 3. And we can apply index law number 3 here, power to a power. That's just the same as x to the power of 2 over 3. What about part 2? Okay, I've got a 2 there. If you see a 2 there, well, what's that? That's just a square root. So square roots are the only surds where if the number's missing, okay, so if that 2 is not there, we assume it to be a square root, in fact. So this is just the same as a square root, but we don't have to show the 2. I just showed it there just to show you that, we need to know how to interpret one of these. Okay, same thing. All right, we've got a to the 5 to the power of a half. Okay, multiply index law number 3, multiply the indices, and we have a to the power of 5 over 2. Last one, all right, the grand finale. All right, we save the best till last. What about this one? It's 1 over something, so there's a negative index there. Okay, so I might write this in a few steps, and then we've got the sort of a fourth root of y to the power of 7. Whoa. Okay, well maybe we can do this in sort of staged. Start off with what's inside the surd first. y on 7. It's being raised to 1/4. It's the fourth root, isn't it? So that's to the power of 1/4. But then we're taking the reciprocal of it. I'm going to use square brackets here. That's to the power of -1. Whoa, we haven't seen this one before. What's going on here? I've got a power to a power to a power. Does index law 3 still hold? Oh, it sure does. You can keep going. Have power to a power to a power to a power. That doesn't end. Right? So there's 3 of them there. You apply the same rule. All right? And that's the beauty of maths. These rules can be applied over and over and over again. It's a bit like Lego, or building blocks. You keep building. Right? Awesome. 7 times 1/4 times -1. Right? Who would have thought? -7 on 4. And that's it. Okay. Hope you enjoyed the video and look forward to creating the next one for you. All the best with your studies.